Problem 303, range sum query immutable. So to solve this problem, we need to know one concept. That's prefix sum. Prefix sum stands for summing all the elements up to that index. So consider an array of 1, -1, 5, 10, -2. The prefix sum, so PS, is going to be the sum of all the elements up to that index inclusive. So up to the first element, it's 1. Up to the second element, it's 0. Up to this element, it's 5. Now notice, how do we arrive at each of these values? Well, how do we get 1? Well, 1 is just by default that value, right? And if we want to get the prefix sum of this value, then it's the net sum up to the element previous to the current element plus that element. So the sum up to the element before -1 is 1. And then we just add -1 to that cumulative sum to get the sum up to that point, right? So this will be 0. And by the logic of that, 0 plus 5 gives 5, 5 plus 10 gives 15, 15 plus -2 gives 13. So therefore, the sum of this entire array is 13. And you might be wondering why we're doing this. The reason why we want prefix sum is because prefix sums gives O of 1 time to find the sum of any sub-array within the overall array. So let's say I just want to find the sum of this chunk. Well, that chunk, it's simply 15 minus 1. And 15 minus 1 gives 14, which indeed is the sum of -1, 5, and 10. So you see that prefix sums give O of 1 time to find the sum of subarrays within it, which comes important for this problem, with a slight caveat. And the caveat comes from this. So basically, we're just given the nums array, and we basically populate the object's parameter or field of nums with that array. And then we want to find the prefix sum of 0, 2, 2, 5, and 0, 5 inclusive. Now notice how we derived the prefix sum previously, right, from above. We know that the prefix sum of this chunk, for example, is 10 minus the elements before, the sum up to the elements before the very first element. So it's 15 minus 1, not 15 minus 0. So how do we account for that? Well, we account for that by simply appending 0 to prefix sum initially. And that makes sense, right? Consider the previous example, right, where we have, 5, 10, -2, right? 0 just stands for basically the sum up to the first element. And originally, we have nothing. So 0 plus 1 gives 1. 1 plus -1 gives 0. 0 and 5 gives 5. 5 and 10 gives 15. 15 -2 gives 13. It's the exact same pattern. We just add a 0 so that we preserve the pattern of how we derive each of the values in prefix sum. And that's the whole idea. We just add the 0 to make it convenient so that once we're actually calculating the prefix sum, it's simply PS of the right index plus 1, right? And why is it plus 1? Because when we add the 0, we shift all the elements to the right by 1. So if we want the prefix sum of 0 to 2, we want this amount. But 5 originally was an index 2, but in the new prefix sum array, its corresponding prefix sum is an index 3. Therefore, we must add 1 to the right index minus the prefix sum of left. And we want to maintain the left without doing anything to it, because by shifting everything to the right by 1, we make sure that prefix sum of left, the elements at the left index in the prefix sum array, is the sum up to the element before the actual left element in the original array. Which you see, for example, 0 to 2, right? 1 originally occupied index 0 in the original array. And in the prefix sum array, it now occupies 1. So the sum of all elements previous to 1 will be in 0, which is exactly prefix sum of left. And with this, we can program it up in Python. So the first thing that we need to do is instantialize the object with integer array nums. So what that basically means is that the object of the class numArray will have a field called nums. And that nums is whatever we want it to be. And we want this to be the prefix sum because, again, that's how we give O of 1 to find each of the sub-array sums. So how do we do that? Well, let's call the new array num. And num is going to be initially just an array with the elements 0. And then we call s to be 0. S is going to be basically the cumulative sum up to that given point. So for n in nums, we simply add that element to s and we append it to nums. It's that simple. And once we're done, we simply define the field of nums to be num. Self.nums, self is basically the equivalent of object, right? So when we call on the underscore init function, we basically initialize an object, and the object is represented in self. So it basically says that object that's calling this function gets assigned the num array for its field nums. The field name is nums, and it gets assigned to num. And with that, we can use it to solve some range. So simply, we just return self.nums to access the nums array, and which index? Well, it's going to be right plus 1, and we subtract that with self.nums of left. And that's exactly as we said in the example, so this should all work, so let's run it. And it works, so let's submit. And that's the solution.